So now let's try applying the knowledge we've learned to work with some examples of quadratic functions. So in this example, we have someone standing on the edge of the roof of the university transfer building, and they're throwing a pumpkin straight up in the air. So the height of the pumpkin measured in feet is given by this function right here. So our input is the variable t, that's the number of seconds after the pumpkin is thrown, and the height of the pumpkin is given by this function, which we're going to write as h. So our first question is the graph of this function going to open up, like this, or down, like this? And as I mentioned before, this is determined entirely by a, which is the coefficient of your x squared variable, or in this case our t squared variable. So because we have a negative coefficient there, when that happens, it's going to open down. Okay. So it's going to open down because a is negative, or you could say a is less than 0 if you prefer to say it that way. Okay, so it's going to open down. Next, I'm supposed to find the vertex of that function. Okay, so let's think about the vertex for a second. We're always going to base this off of finding negative b over 2a, and then plugging that into our function. So let's start with negative b over 2a. So let's see, a is negative 16, b is 20, c is 120. So let's see, negative 20 over 2 times negative 16. That's negative 20 over negative 32. If we put that in the calculator, it should tell us what that comes out to as a decimal, or as a fraction if you prefer. Oops, sorry, negative 20 over negative 32. There we go. So 0.625. So that's the x-coordinate of the vertex. Now to find the y-coordinate of the vertex, all I need to do is take that number and plug it into the function. Okay, so I'm plugging that number into my function for t, and I'm just going to see what that gives me. Okay, I definitely want the calculator to help with this because those are gross numbers. So once I plug all that in, I'm ending up with 126.25. So the answer to the question, find the vertex, well, that's going to be this point right here. Here's the x-coordinate. Here's the y-coordinate. Now let's answer the second part of this question. Based on that, what is the maximum height the pumpkin reaches? Now, because we decided that our function opens down like this, the vertex is going to represent the maximum height of the pumpkin. So the pumpkin goes up for a while, it hits the top, and then it comes back down. So the maximum height is just the height at that vertex. So 126.25, and let's see, the units are feet. Okay, so the maximum height that pumpkin reaches, 126.25 feet. The last question it asks is, when will the pumpkin hit the ground, rounded to 2 decimal places? And to do this, I'm going to let the calculator help out all the way. So I'm going to go ahead and put in this function, negative 16, I can't put t, but I'll put x squared, plus 20x plus 120. If I start with zoom standard, this is not going to be great. Right, I can't really see the whole function. It kind of shoots off the top of the screen. So let me just adjust that a little bit. I'm going to go to Window and bump my Ymax way up. Let's try like 150. And maybe that's good, maybe it's not. Let's see. Yeah, that looks better. Okay, so it goes up for a little bit, it peaks, and then it comes down. Alright, so what I'm supposed to do is find when it's going to hit the ground. So in other words, hitting the ground is a height of 0, so I'm going to find the t-coordinate that corresponds to hitting the ground. So I need to use the 0 feature. So second calc, choosing the 0 feature. I'm going to pick something to the left of that x-intercept, like over here. Then I'm supposed to pick something to the right of it, like over there. And then I'm supposed to give it a guess. So rounded to 2 decimal places, that is 3.43. And let's think about the units. T measures the number of seconds. So 3.43 seconds after the pumpkin is thrown, it hits the ground. Okay, so sometimes we're going to use our tools we've learned about quadratic functions. Other times we're just going to use the graph and find those pieces of information on the graph.